Hello everyone, welcome back to Maximum Automation. In today's video, we are going to discuss how to work with data tables in Reqnroll. If you have previously worked with SpecFlow and are familiar with data tables there, then the approach in Reqnroll is quite similar. This video will help you understand the different ways we can implement data tables in the framework. Even if you have not worked with SpecFlow before, this session will still be beneficial as I'm going to show you the various type of data tables used in feature files and how we can convert that data and how we can use it in our automation scripts. So to start with, let's say we have a scenario in our feature file with a keyword like given user fills the application form with the following details. Suppose our application includes a form where the user needs to input details such as first name, last name, age, roll number, date of birth, and other personal information. In this case, we can create a data table to pass this information to the script definition, which will then be used to populate the actual form in the web application. There are two ways to define this table in the feature file. First one is vertical and the another one is horizontal. A vertical table contains two columns. The first column represents the field name and the second column contains the corresponding value. This format is typically used when there is only one value for each field. For example, to define a vertical table, we create the first row as the header, which will be ignored when passing the table. After the header, we provide the field names and their values, such as first name and the value maximum. And then I'm going to provide the values for different fields like last name, age, and gender. This is how you define the column and the value for each field in a vertical table. If you want to add more entries, you continue adding them vertically in new rows. In contrast, a horizontal table contains a single header row where each cell represents a property name, and the subsequent rows contains the value for those properties. To represent the same data in a horizontal format, we specify the column names in the first row, followed by the data. The horizontal table format is useful when you have a large number of entries or when you need to validate multiple records. For instance, if you want to fill the application form for two different users, in that case, this is how you can define your horizontal table. So first row, I'm going to create the header, that is the column name. And these column names are basically the field name for which we are going to populate the values on the web application. After that, in the second row, I'm going to provide the values for these columns or these fields. So for first name, I'm going to provide the value maximum. Then last name, I'm going to provide the values as automation. And similarly, I'm going to provide the value for each and every field. Now, as we discussed in horizontal row, we can provide the different values. And here, if I want to run the test for different values, then I can provide details in the next row. So I'm going to add another row here, and then we'll provide the second row details for each column. This represents the second set of data. So this keyword is going to run two times, initially with the data from the first row and then with the second row. So in the horizontal format, you can provide the multiple data entries without increasing the length of the feature file. This makes horizontal tables ideal for bulk data scenarios. So vertical tables are more suitable when you have only a few data points to provide. Horizontal tables are better when you have multiple entries and want to manage them more efficiently. If you're only working with a single set of data values, then a vertical table is sufficient. But if your scenario includes multiple records to be tested, then it is recommended to go with the horizontal table. Now, let's understand how we can read this data in our step definition file. The first step is to define this keyword. You can go to this step definition by using the Go to Definition option or using the shortcut provided in your IDE. If the step is not yet defined, the IDE will show an option to create the definition. Looks like here it recognized this step already. So let me just clean the project. Once the project is built, and if there are no caching issues, then you can see now this doesn't identify this step. This says the step is undefined. Now I'm going to right click on it, and then I'm going to define these steps. The moment I'll click on this, this is going to create a step definition for us. So I'll copy the step definition and we'll move to the step definition class. Here we have step definition class, and inside the step definition method, we get a data table object. So now let's see how you can get the values from this data table object, which is coming from the feature file to here in the data table. Now there are different ways to read the values from this object. For example, if I want to get the total row count of the table, then to get the row count, we can use datatable.rows.count. Let me also print this value into the console as well. For instance, let's say we have a data table with 4 columns, that is first name, last name, age, and gender. You can loop through the rows and print the column names and values. For that, I'm going to create a for each loop, and then I'm going to iterate through all the rows we have in the data table. First, I'm going to print the column name, and then I'm going to print the value of that column. So to get the column name, what we need to pass the field, which was the header, which contains the column names or field names. So this is going to print the field names of each row. And then this is data row value is going to print the values against those field names. Now I'm going to debug the test and show you how the values are retrieved from the data table. When you run the test, you will see the output in the console with the column name and their corresponding values printed out. You can see this shows the row count. So we have total row count as 4 because we have 4 rows defined in our feature file. So the first row is always treated as the header. After that, the header, next sets of data will be treated as rows. So here it says the total row count we have is 4. Now, if I move further, then we'll see what this data table object contains. So if I go to this data table, so what I'm going to do now, I'm going to add these data table field, data row field, and data row value into the watch screen. And then you can see this displays the value for the field name, that is first name, and the value of that field as maximum. And after that, if I move to the second iteration, then you can see the field name changes to the last name and the value changes to the automation. So this is how you can read the values basically for the vertical data tables. Now we're going to see how we can read the values from the horizontal data table. As you can see, the first row in the horizontal table contains the column names and the subsequent rows contains the values. The process of retrieving values is similar to the vertical table, but the key difference is how the data is structured. First of all, I'm going to keep only one row, and then we'll see how we're going to read the values. First of all, I'm going to read the first name of the data table. Here, I'm going to print the values based on the column names. So this time, we don't need to get the field name because we know what is the field name. So the field name is first name, that is our column name. So this is going to print the value for the column first name. And then this one is gonna print the value for the column last name. Similarly, we can print the values for different columns we have in our horizontal data table. So this is how you can read your horizontal data table values, directly providing the field name into the data row object. So currently this loop will run only once because we have added only one entry in our feature file. Now, let's say if I add another row in our keyword, so now we have two rows. This is going to run 2 times, and this is going to print the values. Let me again debug the test so that I can show you how the values are retrieved for the data table, the horizontal data table, which we have created. So if you add multiple rows in the horizontal table, it will loop through each row and you'll see the data for each iteration. So this time you can see the row count is 2 because we have only 2 rows in the horizontal table. And if I move further, then let me add these values into the watch. So I'm going to change the field name to first name here. You can see the first name coming as maximum and the last name is coming as automation. And now if I move to the next iteration, that is the second row in the data table, then you can see the values change to the first name is Marcus and the last name is Hot. So this is how we can read our values from the data coming in form of the data table from the feature file. Either you create horizontal table or vertical table. So in the next session, I'll cover how you can read the data from the table using classes. Currently, we have used the data table object to read the values, but we can create different classes to represent the data table, and then we can map the values from the data table into the class properties. This will allow for more structured and readable code. So stay tuned for that in the next video. I hope you found this video useful. Please leave your comments in the comment box and don't forget to like and subscribe to the channel. Thank you.